So guys, it's time to get real. We are no longer going to pretend like we know the truth about the population. Instead, we will use data from a random sample or a randomized experiment to create an interval of possible values for the population parameter. We will estimate this parameter from our point estimate, x bar or p hat. So some important vocab. The first one is point estimator. This is a statistic that provides an estimate of a population parameter. For example, the proportion of students in an SRS from period 5 who have been to Disney World would be a point estimator. A point estimate is the value of the point estimator. This is ideally our best guess at the value of an unknown parameter. An example would be p hat equals 0.79. This is a value, 0.79, that is a point estimate because it is a possible proportion of students who have been to Disney World. So point estimator is what we are measuring. The point estimate is the actual value of that measurement. Article taken from USA Today. I edited a little bit for saving some space. So if you want to take a second and read what it's about, you should do that now. So as you can see, the headline reads, 24% of Americans stop buying online because of breaches. This article is assuming that the population parameter is 24%. They're making that conclusion based off of the results of their sample survey. So in this article, the population are Americans who do or used to do their internet shopping. And the parameter of interest is the proportion of those internet shoppers who stopped shopping online due to the recent security breaches. The article says that they sampled 790 randomly selected individuals, and our point estimate is 24%. 24% from those surveys said that they did stop buying online due to the security breaches. Notice this article states that the survey has a margin of error of plus or minus 4 percentage points. What does this even mean? To answer this question, let's draw the sampling distribution of sample proportions for a sample size of 790. Since our parameter of interest is the proportion of adults who no longer shop online due to the security breaches, we will be constructing a sampling distribution for p hat. So of course we check our conditions. Our first one is whether or not we can use a normal approximation. Since we don't know what p is, we can't check these conditions. However, since this is a large sample, we can use the value of p hat in place of p. So we can check these conditions. So 790 is our sample size. We believe the population parameter to be 0.24, and these are both satisfied. So sweet, we can use a normal approximation. Our other condition is to check for independence. So we need to make sure that our population is at least 10 times larger than our sample. So 790 is our sample size. Is our population greater than or equal to 7,900? I think it's safe to assume that there are at least 7,900 Americans who used to or currently shop online. Since this is fulfilled, let's put a double check, and sweet. We can now use our formula for standard deviation since the scenario is independent. So here's our formula for the standard deviation of a sampling distribution for p hat. We said that instead of p, we're going to use p hat as our approximate value for the parameter. We replace those values, and when I round it, our standard deviation is approximately 0.02, or 2%. Since we're assuming that p hat is close to p, we're also going to assume that the center of the sampling distribution is also going to be p hat. So we know that the center of a sampling distribution is the same thing as the population parameter. In this case, we're assuming that the parameter is the same thing as the statistic. So by transitive property, we can assume that our center is also going to be 0.24. And then we can fill in the rest of our sampling distribution using our standard deviation. So let's go back to our original question. What does margin of error or plus or minus 4 percentage points mean? So looking at our sampling distribution, we can help answer this question. Margin of error tells us how close our estimate tends to be to the unknown parameter in repeated sampling. In this survey, the article says that there's a strong likelihood that the true population parameter is within plus or minus 4% of the estimate from our sample. So here's minus 4%, here's plus 4%. This means that we can expect the true proportion of individuals who stop shopping due to the security breaches to be between 20% and 28%. The interval 20% to 28% is called a confidence interval. This is not set notation, so you don't have to worry about brackets or parentheses. We're using parentheses to represent the interval. So a confidence interval is an interval calculated from data which has the following form. We use our estimate, and then we add and subtract our margin of error. This gives us a plausible interval in which we believe the true population to be contained within. So notice our estimate was 24%. We take away the margin of error, which is 4%. So 20% is our lower bound for our interval. Again, our estimate is 24%. We're adding our margin of error, so our upper bound for the interval is 28%. So again, we believe that the actual number of individuals who stop shopping due to security breaches to be between 20% and 28%. So let's shade the area within our confidence interval, 20 to 28%. What percentage of possible statistics does the confidence interval capture? Well, we know from our empirical rule that the percentage between 0.2 and 0.28 is approximately 95%. In this case, this particular survey has a confidence level of 95%. How many standard deviations away from the mean is this confidence interval? Well, since we're going 95%, we know that that's within 2 standard deviations of the mean. 2 is called the critical value because our confidence interval is within 2 standard deviations of the mean. Identify the confidence level and critical value for the following confidence intervals. As you can see, the area shaded is 68% of the data, approximately, which corresponds to our confidence level. So the confidence interval here has a 68% confidence level, and we know that 68% is approximately 1 standard deviation away from the mean, so our critical value is 1. In this picture, we see that the shaded area is approximately 99.7%. That is also our confidence level. And we know that 99.7% is within 3 standard deviations of the mean, so our critical value is 3. So let's practice our new vocab. It is practically impossible to find out the time spent studying per night for every high school student in the country. Instead, we select a sample of students and find that the average time spent studying to be 35.6 minutes per night with a margin of error of 5 minutes. Identify the point estimator. So we're interested in the average time spent studying, and the point estimate is the actual value we got from that, which is x bar equals 35.6. We're using x bar because it is a sample and because the symbol for sample mean is x bar. This scenario says the margin of error is 5 minutes. So remember, margin of error is plus 5 minutes or minus 5 minutes. So to find the confidence interval, we know it's going to be our estimate plus or minus our margin of error. So I took my point estimate of 35.6, subtracted margin of error, and then I did it again, but I added the margin of error. So we see that our confidence interval is between 30.6 and 40.6. So what does this mean? Well, this means that we believe that the time spent studying per night for United States high school students is between 30.6 and 40.6 minutes. We believe this to be likely. Is this necessarily going to be true? No, but we're going to talk more about error later. A survey that asks randomly selected individuals, do you like chocolate, wants a confidence level of 95%. 80% of the survey responded that they did indeed like chocolate. The standard deviation for the sampling distribution is 0.025. This time our point estimator is the percentage of individuals who like chocolate. And our point estimate is the actual value of that from our survey, which is p hat equals 0.8. Again, since this is a proportion taken from a sample, this is going to be p hat. Well, we don't know explicitly what margin of error is, but we can find it. We saw that margin of error is the critical value times the standard deviation of the sampling distribution. Since we're talking about 95% confidence, that means the critical value is 2, because 95% is within 2 standard deviations of the mean, and we're told that the standard deviation is 0.025. So the margin of error is going to be plus or minus 0.05. So our confidence interval is going to be 0.8, our estimate, minus 0.05, and 0.8 plus 0.05. So our confidence interval is 0.75 to 0.85. What does this confidence interval mean? We believe that between 75% and 85% of individuals like chocolate. We believe this to be likely. It doesn't necessarily mean it's always going to be the case, but again, we'll talk about error later. This time, a survey that asked randomly selected individuals, do you like chocolate, wants a confidence level of 68%. 80% of the survey responded that they did indeed like chocolate. Standard deviation for the sampling distribution is 0.025. So again, our point estimator is proportion who like chocolate. Our point estimate is the same, but this time we're changing our margin of error. Our critical value is going to change because instead of using a 95%, we're using a 68%. So if you imagine 68% is between 1 and -1 standard deviations. So the critical value is going to be 1. Standard deviation of the sampling distribution is the same. So this time our margin of error is 0.025. So our confidence interval looks like this. We subtract 0.025, we add 0.025. So our confidence interval is from 0.775 to 0.825. So this means that we believe that 77.5% and 82.5% of individuals like chocolate.